Hello friends, today we will learn about biomass and bioenergy. So let's begin. The capacity to do work is referred to as energy. Energy may be considered as a form of matter which is interconvertible. The modern man is mostly dependent on three sources of his energy needs, that is, coal, natural gas, and oils, collectively referred to as fossil fuels or fossil energy sources. The fear of depletion of global fossil fuels has forced man to look for suitable alternative energy sources such as solar, hydro, tidal and wind power, and more recently, nuclear energy. In addition to these advances in biotechnology, have applied to fruitfully utilize the energy from biological systems. Now, let's know about biomass. Biomass is the total cellular and organic mass produced by the living organisms. It is the primary product of photosynthesis and is a good source of energy, that is bioenergy. Broadly speaking, biomass represents all forms of matter derived from biological activities. These include plants and agricultural products, microorganisms, animal waste, and manure. The term biomass is also used to collectively describe the waste materials produced in food and agricultural industries. Besides being a good source of energy, biomass is important for the production of several commercial important products. Thus, biomass is appropriately regarded as a renewable source of energy which can be directly converted to energy or energy carrier compounds by various means. In most developed countries, biomass is utilized for the production of industrial and commercial products, ethanol, oils, methane, single cell proteins, etc. In contrast, in the developing countries, India, Latin America, and Africa, a major part of the biomass is directly used as a source of energy as firewood. It is estimated that the annual net yield of plant biomass is around 175 billion tons of dry matter, that is 125 billion tons on land and 50 billion tons on oceans. Forests significantly contribute to the production of land based biomass around 45%. Agricultural crops on the cultivated land account for about 6% of the plant biomass. The agricultural biomass products, that is cereals, pulses, oils, animal feed, etc., adequately meet requirements of foods for the human beings and animals. Besides their basic needs, that is fuels, chemicals, etc. From a chemical point of view, about 50% of the land product produced biomass is in the complex from the form of lignocellulose. Okay. Now let's know about fossil fuel derivatives of biomass. The modern society is dependent on the non-renewable sources of energy, namely oil, gas, and coal. These fossil fuels are actually derives of ancient biomass. It took millions of years for the fossil fuels to be deposited beneath the earth and oceans. However, in just within a century of exploration, the major fuel reserves, particularly gas and oil, are depleted, and at the present rate, they are not likely to last long. As such, there exists an energy crisis throughout the world. Consequently, researchers continue their for alternative and renewable sources of energy. Now let's know about photosynthesis, the ultimate source of energy. Photosynthetic organisms are the ultimate sources for trapping the solar energy. In the presence of the photosynthetic pigment chlorophyll, carbon dioxide is converted into complex carbohydrates within the evolution of oxygen. Now let's know about the reaction. Carbon dioxide plus water gives rise to, in presence of chlorophyll and light, gives rise to CH2O plus oxygen. In the reaction that follow later, solar energy is trapped into molecules such as fat and proteins besides other complex carbohydrates like cellulose, hemicellulose, lignin. Photosynthetic organisms are the true solar energy converters. It is estimated that at present more than 10 times more energy is generated by photosynthesis annually than consumed by the world's population. Unfortunately, the role of photosynthesis is not well recognized to solve the present day problem of energy crisis. This despite the fact that it is not only photosynthetically produced biomass that is available today in the form of fossil fuels. The biomass produced by photosynthesis can be appropriately utilized for the production of fuels, alcohol, methane, and various other commercial products. Now let's know about chemical nature of biomass. The plant biomass is mainly composed of cellulose, hemicellulose, lignin, starch, proteins, water soluble, that is sugar, amino acids, and fat soluble oils and pigments compounds. In fact, majority of these constituents are present in the plant cell wall. There is a wide variation in the chemical composition of the biomass depending on the source. For instance, the biomass obtained from sugar cane and beet sugar is rich in sugars, while the biomass of potato and tapioca is rich in starch. On the other hand, cotton has a high content of cellulose. The chemical nature of biomass derived from industrial and municipal waste is highly variable, which mostly depends on the sources that contribute to the biomass. Now, let's know about the sources of utilization of biomass. The major sources of biomass are natural vegetation, energy crops, and agricultural, industrial, and urban organic waste. Their production in turn is dependent on the solar energy. The natural vegetation, growing natural forest and aquatic weeds, significantly contributes to biomass. Wood-rich plants are grown in many countries, particularly developing countries, to generate fire for cooking and other purposes. In recent years, well-planned and organized plantation are carried out in some countries to produce biomass to meet energy demands. For instance, sugarcane and cassava plantations in Brazil and Australia are used for ethanol production. Plants rich in lignocellulose are grown in America and Sweden, which are useful for the production of liquid fuels, that is ethanol, methanol. Agricultural, industrial, and municipal waste were earlier considered as useless and discarded, but in the recent past, many countries have developed methods for converting this waste into biofuels and commercially important products. The successfully used agricultural waste include straw, bio, biogases, brain, cotton waste, etc. Among the industrial waste, molasses, whey, distillery wastes, and sewage are the important ones. As already stated, the biomass is utilized for the production of biofuels and various other compounds. The technique mainly depends on the chemical nature and moisture content of biomass. Now let's know about combustion. Low moisture containing biomass, that is wood, straw, brain, can be directly burned by a process referred to as combustion to generate electricity. Let's know about dry chemical processes. The biomass with little moisture content can be subjected to various dry chemical process pyrolysis, gasification to produce methanol, oil and ammonia biomass. Now let's know about aqueous processes. The biomass with high water content is used in aqueous process such as fermentation to produce ethanol, oils and methane. The biotechnological strategies for the production of biofuel, that is alcohol and hydrogen from biomass, are now found from jatropha plants. Now let's know about the production of alcohol from biomass. Alcohol chemical ethanol, that is C2H5OH, has been produced by fermentation for thousands of years. Although the developed countries these days prefer to manufacture ethanol by chemical means, the developing countries continue to produce it by microbial fermentation. Alcohol in the Alcohol is the liquid fuel which is the mostly produced from the biomass. The raw materials, that is biomass, used for alcohol production include starchy materials, that is wheat, rice, maize, potato, and cellulosic material like wood, agricultural waste, etc. Now let's know about the production of biogas from biomass. Biogas is a mixture of gases composed of methane, that is 50 to 80%, carbon dioxide, that is 15 to 40%, nitrogen, that is 4%, and hydrogen sulfide, that is 1%, with traces of hydrogen, oxygen and carbon monoxide. There are many other common names for biogas: gobar gas, sewage gas, Clear gas and sludge gas. Biogas is a gaseous fuel and serves as a good source of energy for various purposes. It can be used for cooking purposes on combustion. Gobar gas can generate electricity. It can be purified to yield good grade methane. Methane gas is extensively used as a fuel for domestic and industrial purposes. It is employed for the generation and electrical, mechanical and heat energy. It is estimated that under ideal conditions 10 kg of biomass can produce 3 mq of biogas. This biogas can provide 3-hour cookings, 3-hour lighting, or 2-hour refrigeration with suitable equipment. The calorific value of biogas with 80% methane is around 8,500 calorie per meter cube, per mq. Biogas. Now let's know about biogas production in different countries. How biogas is produced in different countries we will discuss now. So biogas production significantly contributes to world's energy sources. China has the largest number of biogas or gobar gas systems with an estimation of 7 million units. Government of China encourages and offers subsidies for construction of biogas units. As a result, the cost of biogas plant is cheaper than a bicycle in China. Governments in many developing countries also encourage installation of biogas plants. In India, government provides 25% subsidies. Besides encouraging banks to offer loans for construction of biogas plants, they are becoming popular in rural areas. Pakistan also has a good number of gobar gas plants. Now let's know about the substrates for biogas. The usual substrates for biogas production are the waste products of animal husbandry, industries, agriculture and municipalities. In India and other developing countries, cattle dung, that is gobar, is most commonly used. The major raw material for biogas in China is pig dung. The concentration of organic dry matter is or total solids, in short TS, is useful for grading the industrial, agricultural and municipal wastes. Thus, low grade, that is less than 1% TS, medium grade means 1 to 5% TS, high grade means 5 to 20% TS, and solid means 20 to 40% TS waste are available. Solid or high grade waste are preferred as substrates for biogas production. In general, most of the substrates used in biogas plants contain adequate quantities of almost all the essential nutrients required for microbial growth. If necessary, nitrogen, phosphorus, and trace elements are added. A carbon nitrogen ratio less than 40 is to 1 is preferred for optimal biogas formation. Water hyacinth, that is Ecornia crassips, an, an aquatic weed with huge biomass, is a good source, that is raw material for methane production. With high carbon nitrogen ratio and low lignin content, the yield of methane is high. Another adequate weed is azolla, is equally important for methane generation. Now let's know about the microbial production of methane biogas. Methane is the most abundant constituent of biogas. It is also be directly used for various domestic and industrial purposes. The microbial generation of methane, appropriately referred to as. Now let's know about hydrolytic phase. Certain facultative anaerobic bacteria hydrolyze the complex organic materials of the biomass, that is cellulose, starch, proteins, lipids, to low molecular weight soluble products and some organic acids. Now second phase is acidifying phase. This phase is characterized by more formation of organic acids besides hydrogen, carbon dioxide, and alcohol. Third, then third phase is acetogenic phase. Acetogenic bacteria convert alcohol into acetate. These bacteria also generate acetate from H2 and carbon dioxide. Methanogenic phase. Let's know about methanogenic phase. This is the actual phase of the methane gas formation. The methanogenic bacteria, example Methanobacterium omelianski M. formicicum and M. bryantyi methanosar Sarcina Barkeri convert acetate and carbon dioxide and H2 hydrogen into methane. Let's know about the reaction. Reaction is CH3COOH gives rise to CH4 plus CO2. Another reaction is 4H2 plus carbon dioxide CO2 gives rise to CH4 plus 2H2O. Some other substrates like formate and methanol can also be converted to methane. That is 4HCOOH gives rise to CH4 plus 3CO2 plus 2H2O. Another reaction is 4CH3OH gives rise to 3CH4 plus CO2 plus 2H2O. The overall reaction of methane formation from glucose as the starting material may be represented. C6H12O6 gives rise to 3CH4 plus 3 carbon dioxide. The complex polysaccharide, particularly lignin and cellulose, due to their inefficient conversion, limit methane production. In the normal process of methanogenesis, approximately 50% of the complex polysaccharides contribute to methanogenesis. Now, let's know about the process of biogas production. How biogas is produced. Biogas production from biomass is an anaerobic process. The anaerobic digestion is usually carried out by using airtight cylindrical tank, which are referred to as anaerobic digesters. A digester may be made up of concentric bricks and cement or steel, usually built underground. The digester has an inlet usually built underground. The digester has an inlet attached to the mixing tank for feeding cow dung. The methanogenic bacteria from another digester also are also added with cow dung. The digester is attached to a movable gas holding or storage tank with a gas outlet. The used slurry, spent cow dung, comes out from the digester through an outlet. This can be used as a manure. The anaerobic digester described till now is a low technology gobar gas plant commonly used for domestic purposes in rural areas in India. The process of digestion usually takes about 2 to 3 weeks when cow dung is used as a substrate. Now let's know about landfill sites for methane production. Landfill sites are low cost digesters built underground for the digestion of solid waste, that is of industrial and municipalities. As the anaerobic digestion of solid organic material occurs, methane gas is generated. It can be recovered by boring gas wells into the top of the landfill. Now let's know about the factors affecting biogas, that is methane production. The factor affecting methane production with special reference to biogas plant now we will discuss. First is temperature and pH. The ideal temperature is 30 to 40 degrees centigrade, while the pH is 6 to 8 for good yield. And second is slurry composition. The ratio between solid and water composition in the slurry should be around 1 is to 1. A carbon nitrogen ratio of 30 is to 1 in the slurry results in the optimal methane production. Good mixing and solubilization of the organic constituents is required. Third is anaerobic condition. The digester should be completely airtight so as to create suitable anaerobic conditions. Presence of inhibitors come aluminum sulfate and antibiotics inhibit methane production, agricultural waste, pig and chicken manure, generating ammonia and waste from paper, that is rich in sulfate, inhibit biogas production. Now let's know about the advantages of biogas production. By using a simple technology, agricultural, industrial and municipal waste can be converted into a biofuel. The left over residue after biogas formation can be used as fertilizers. Thus, the waste materials that would cause environmental pollution are fruitfully utilized for biogas and fertilizer production. Now, let's know about limitations for large scale production of methane. Although production of methane as a constituent of biogas is ideally suited for domestic purposes, many people argue against the large-scale commercial production of methane for some reasons. Let's know about the reasons. Methane is abundantly available in the natural oil and gas field, gas fields, that is produced by the same mechanism of methanogenesis over a period of years. Second point is microbial production of methane is more expensive more than its isolation from the natural gas. Third point is methane production for by gasification of coal is more economical than its production from biomass. Now let's third point. Let's know about the fourth point. Fourth point is being a gaseous fuel, it is quite difficult as well as expensive to store, transport, and distribute methane. Fifth point is methane is unsuitable for use as a fuel in automobiles. This is because it is very difficult to convert the gaseous methane into liquid state. Despite the limitations listed till now, thank you. Little bit. Now let's know about hydrogen, a new biofuel. Hydrogen is a simple molecule which can be easily collected, stored as a gas or liquid and transported. It is highly combustible. It is highly combustible and can be used as a fuel or for the production of electricity. Hydrogen on mixing with oxygen provides around 30,000 calories per gram as compared to 11,000 and 8,000 calories per gram of gasoline and coal respectively. Further use of hydrogen is environmental friendly since it is a non-pollutant. Hydrogen is truly a versatile fuel. It can be used for automobiles, aeroplanes, helicopters, buses, cars and scooters. Liquid hydrogen is considered to be an ideal fuel for subsonic and supersonic aircraft worldwide. Now let's know about production of biohydrogen. There are mainly two ways of generating biohydrogen by photosynthetic bacteria and by fermentation. Now let's know about the by photosynthetic bacteria. Biological production of hydrogen can be achieved by photolysis of water by photosynthetic algae and bacteria, a phenomenon referred to as biophotolysis. Certain microalgal and cyanobacteria, example chlorella, chlamydomonas, Chenodesmus, microcystis, oscillatoria, annavina can generate molecular hydrogen. Water is the source of raw material. H2O in photolysis gives rise to oxygen plus hydrogen plus electricity. H Another reaction is H plus H plus in presence of hydrogenase gives rise to H2. The action of hydrogenase can be inhibited by creating oxygen pressure and this condition favors release of free hydrogen. Isolated chloroplast along with the bacterial enzyme hydrogenase have also been used for production of hydrogen. Now let's know about the by fermentation. It is possible to produce hydrogen from glucose and by bacterial action. However, the yield is less and uneconomical. Hydrogen can also be generated by anaerobic fermentation by a process comparable to that of methane production. This is also not economical besides being low in efficiency. Photosynthetic bacterium rhodospirillum can be used to produce hydrogen from organic waste. Now let's know about by legume crops. The leguminous plants convert N2 to NH3 and H2. This reaction is catalyzed by the enzyme nitrogenase. In the normal circumstances, this H2 gas A byproduct of nitrogen metabolism is lost in soil. It is estimated that from a soybean crop in 1 hectare field, about 30 billion 3 m³ hydrogen is generated and lost annually. As such, there are no methods available to trap such huge quantities of hydrogen produced in agricultural fields. Now, let's know about energy rich crops. Some of the plants are very efficient in converting carbon dioxide into biomass, and such plants are collectively referred to as energy rich crops. Now, let's know about these crops. First is sugar and starch crops. Certain plants like sugarcane, sugar beet, cereals, and tuber crops produce high quantities of starch and fermentation as sugars. These crops supply energy-rich foods and feeds. Such plants are useful for production of biofuels, particularly ethanol, often referred to as bioethanol. Now let's know about wood-rich plants. Some plants grow very fast and they serve as good suppliers of wood. Example: eucalyptus, butea, Melia, Casuarina, like this. These plants are important sources of firewood. It is estimated that approximately 50% of the total wood harvested annually is utilized for the purpose of firewood. Wood is also useful for the supply of pulp for paper manufacture. Now let's know about petroleum plants. There are certain plants which can accumulate high molecular weight hydrocarbons. They are referred to as petrocrops and or gasoline plantations. The production of these hydrocarbons rich plants can serve as good substitutes of conventional petroleum and petroleum products. The rubber plant, that is Havia rubber, grown in the Southeast Asia in the principal source of rubber. Rubber is collected in the form of latex from the stem of trees, stems of the trees. This plant meets about one third of the total world's demand of rubber. However, the rubber produced from petroleum is referred for use in automobiles and planes due to low cost and high elasticity. Besides heavier rubber, there are some other plants for the production of natural rubber. Example: Parthenium agrigentum, mm, Taraxacum coxsackie, that is Russian dandelion, grown in Mexico and some parts of USA. Euphorbia lanthyrus and E. tarucali contain high contents of terpenoids, complex hydrocarbons that can be directly converted to gasoline or petrol. It is estimated that E. tarucali can yield about 5 to 10 barrels of oil per acre per year. Eggplant, that is Calotropis procera, secretes lactase which is very rich in hydrocarbons. These hydrocarbons and yield are comparable to Euphorbia lathyrus, and they also serve as good substitutes of petroleum. For obvious reasons, the cultivation of petroleum plants is encouraged throughout the world. Now let's know about the future of biomass. Future of biomass. Besides its utility for the generation biofuels, alcohol, methane, biomass is also used for the production of butanol, acetone, single cell protein, and many other products. As such, the contribution of biomass to the world's requirement of energy is very low. It is around 5% of the USA, may be a little higher in the developing countries. However, being a renewable source of energy, biomass will have the immense value in future. This is particularly true as the world's non-renewable fuel, that is gas and oils, get depleted. There is a growing realization on the fuel value of biomass. In the coming years, biomass production and utilization strategies will be fully exploited. In addition, further improvements in the biotechnological process for better management and utilization of industrial, agricultural, and domestic waste will also solve the problem of world energy crisis. Finally finished. Any questions regarding this, you can ask me in the comment box. I will definitely answer the questions. And subscribe my channel for more updates. Thank you.